In this video, we're going to be solving slightly more complex gas stoichiometry problems. We're going to be going from mass of one substance to volume of another, and volume of a substance to mass of another at STP. Now remember, standard temperature is 273 kelvins, and standard pressure is 1 atmosphere. One thing I want you to do is, for the purposes of just these problems, and you don't have to do it, but is to reverse the direction that the moles and volume go. So you're going to be having the volume to moles go up and dividing by 22.4, so you'll reverse the operation, and from moles to volume we'll be multiplying by 22.4. The only reason why we're doing this is to make it a little bit more chemically correct. You can go about doing these problems without reversing this and taking a different path, but I would recommend doing it this way just to make it a little bit more correct. So let's solve a problem here. We have at STP, calcium carbonate is decomposing to form carbon dioxide and calcium oxide. We want to know how many grams of calcium carbonate will you need to form 2.3 liters of carbon dioxide. So we're given information about a volume, and we need to figure out information about a mass of a different substance. So we'll be starting with volume of one substance, and then going up to moles, then over to moles of the new substance, and then figuring out how heavy that new substance is. So when I start my problem, the first thing I need to do is I need to, of course, balance my equation. So I start out with calcium carbonate. Now, calcium has a positive 2 charge. Carbonate is a polyatomic ion with a negative 2 charge. So they'll be combining at a 1-to-1 ratio. So the compound is CaCO3. Now that decomposes into calcium or carbon dioxide and calcium oxide. Now, calcium has a positive 2 charge. Oxide has a negative 2 charge. They also combine at a 1-to-1 ratio. So it's CaC or CaO. When I balance this equation, really easy to balance, I have a 1-to-1-to-1 ratio of all of my my molecules. Now, the information that I'm given is for carbon dioxide, so I'm labeling that as A. B is the information I want to try to find. So I want to try to find out information about calcium carbonate. Now, the first thing I'm going to do is I'm going to list my 2.3 liters of carbon dioxide. So I have 2.3 liters of carbon dioxide. The next step that I want to take is I want to figure out how many moles that is. Now this is at STP. So essentially all I'm going to be doing is dividing by 22.4, because at STP, 22.4 liters is the volume of 1 mole of any ideal gas. So now I figured out how many moles of carbon dioxide I have. The next thing I want to do is figure out how many moles of my new substance that I will have. So 1 mole, and I use the balanced equation for this, 1 mole of CO2 is created by 1 mole of CaCO3, using that balanced equation, using the coefficients of the balanced equation. So now I know how many moles of calcium carbonate I have, but I want to figure out how heavy that is. So I multiply by the molar mass, and I find that on the periodic table, the molar mass of CaCO3, which is 100 grams per mole. Multiply this all out. I have 2.3 liters of CO2 times 100 divided by 22.4 liters, and what I end up with is 10, rounded to 2 significant digits, 10 grams of calcium carbonate. So 10 grams of calcium carbonate is needed to produce 2.3 liters of carbon dioxide gas at standard temperature and pressure. Let's try a second problem. We have chlorine gas and acetylene, and they react together to form liquid C2H2Cl4 at STP again. How many liters of acetylene will be needed to produce 18 grams of this C2H2Cl4 stuff? So in this situation, we know information about a mass of one substance, and what we want to try to find is information about the volume of a different substance involved in that chemical reaction. So here's our plan of attack. We're going to divide by the AMU, or molar mass, of the substance A. Then we're going to multiply by the coefficient of B over the coefficient of A, and then we need to figure out how many liters that is. So we'll be multiplying by 22.4 because we're at STP. the first thing I need to do to solve this is write out my equation. So this is a synthesis reaction. We have chlorine gas, which is diatomic, Cl2, reacting with acetylene, C2H2, to give us C2H2Cl4. Now if I want to balance this, I notice that I have 4 chlorines on the right, so I need 4 chlorines on the left, and then I'm just going to fill in 1s in the remaining compounds. So this is my balanced equation. Now I'm going to label A for the C2H2Cl4 because that's the compound that I know information about. I don't know information about the acetylene, and that's what I want to try to find. So I'm going to label that as B. I start out with my 18 grams of C2H2Cl4, and the first thing I want to do is I want to figure out how many moles that is. So to do that, I have to divide by the molar mass of that compound. So I add up 4 chlorines, the mass of 4 chlorines, the mass of 2 carbons, and the mass of 2 hydrogens. And I find out that the mass of 1 mole of this C2H2Cl4 business is 168 grams. So that's the molar mass of this compound. Now I know how many moles of this compound I have. Now I want to figure out how many moles of my acetylene I will need to create that number of moles of C2H2Cl4. So this is easy. This is a 1-to-1 ratio because I use the coefficients of my balanced equation of those substances and figured out this ratio, coefficient of B over coefficient of A. The last step is I want to figure out the size, the volume of this amount of acetylene gas that is required to make this substance. So I have 22.4 liters of acetylene gas over 1 mole of acetylene gas. So now I can figure out how many liters of acetylene gas I need to create this 18 grams of this C2H2Cl4. So I type in 18 times 22.4 divided by 168 on my calculator, and I end up with 2.4 liters, and that's rounded to 2 significant digits, 2.4 liters of C2H2.